Projectiles Type 4A, striking a target. So in 2010 we were given a room of height 6 metres and a ball projected from a point P, and this time not starting at the ground, it's starting above the floor, and we're given the velocity and the angle of projection. The ball, we're told, strikes the ceiling at Q. So it's striking the ceiling at Q without first striking a wall. So what that basically implies is if we were to draw a diagram of our projectile path, we have a starting point of 1.1 metres above the ground. So this height here is 1.1 metre, and it's starting from the point P, so that's P there. And the projectile path is such that the highest point it reaches is the ceiling. And therefore that height above the ground is 6 metres. However, you have to be careful with this one because obviously it's not starting from the ground, and therefore if I continue that all the way across, the distance, the SY in this case, I'll just use a different colour. The SY in this case will be the difference there. So 6 minus 1.1 metres gives us 4.9 metres. And the angle of projection, we're told, is 45 degrees with respect to the horizontal, so that's 45 there. And we're given an initial velocity of 9.8 root 2 metres per second. So we have a diagram there for starting, and we have 2 points that we're referring to in this question, P being the starting point and Q being the final point, the point where it just hits the ceiling. So it's not bouncing off the wall or in terms of the ceiling at the top or at the side, it's literally aiming at the edge there at Q at the ceiling. So what they want us to do is find the length of the straight line between P and Q. So if I just use a different colour here, so we have to basically find here is the distance from P to Q. Now straight away we can clearly see that this is going to be a right angle triangle that we're looking for. And therefore we're going to need to get the hypotenuse. So we know 4.9 is going to be the side of the triangle, the height of the triangle, and the base of the triangle will be the range S of x. And therefore we use Pythagoras, we'll be able to find the distance from P to Q. Okay, so before we start, we're just going to have a look at the fact that we're given an angle this time. So the fact that we're given an angle, I'm going to write down the angle alpha. In other words, the angle of projection is 45 degrees. So if we come across sine 45, then that's going to be 1 over root 2. And if we come across cos alpha, that's going to be cos 45, which is also 1 over root 2. And of course, if for any reason we ended up with tan alpha, well, tan 45 is our favourite because that gives us 1. Okay, so we're going to start by filling out our table. So we have U, A, V, S and T. And of course we want to do it in terms of X and Y or I and J, whichever you prefer. And you're going to fill out the table, so you're going to press pause in the video and then complete your table if you haven't already done so. Okay, so if we have U cos alpha and U sine alpha, well, if I just write to the side here, U cos alpha is going to become 9.8 root 2, and cos alpha is 1 over root 2. So of course the root 2's are going to cancel, leaving us with 9.8 for U cos alpha. So U in the x direction is 9.8. If I do U sine alpha, well, U is 9.8 root 2, and sine alpha is also 1 over root 2, And therefore, again, our root 2 and our root 2 cancels. So again, u in the y direction is also 9.8. We know that there is no acceleration in the x direction. And we know then, because u is in an upward direction, that our gravity is in the opposite direction. And therefore, we end up with minus 9.8 for gravity. Now, of course, you can write it in terms of g also. It doesn't make a difference until the very end, and then you can sub in for g if you wish. For our v, we have v is equal to u plus at, and s is equal to ut plus a half at squared. So by subbing in to our equations there, we end up with v in the x direction is 9.8, v in the y direction is 9.8 minus 9.8t, s in the x direction is 9.8t, s in the y direction is 9.8t, minus a half of 9.8 is 4.9 t squared, where we have t, our time in terms of t. Okay, so in order to find the length of PQ, we've already stated there that we are going to need to work out our s of x, our range. Now, if I look at the equation there for s of x, I can see it's 9.8t. So therefore, I need to work out what is the time of flight. So I know my time of flight is going to occur when I have s of y is equal to 4.9 meters. So again, be careful not to do s of y equal to 6 here, because that is not the height above its starting position. The height above the starting position is 6 minus 1.1, in other words, 4.9 meters high. So if I let s of y so on landing, or striking the wall, or the ceiling I should say, then we know that sy is equal to 4.9 meters. So this will allow me to work out my time of flight. So sy we saw was equal to 9.8t minus 4.9 t squared. So if I equate that to 4.9, then I end up with a quadratic equation, which is 4.9 t squared minus 9.8t plus 4.9 equals 0. And I can divide across there by 4.9. You might not spot that, in which case you probably just go straight to the minus b formula, and that's fine. But if you do divide across by 4.9 there, what you'll end up with is a nice little quadratic where our factors that multiply to give us 1 and add to give us minus 2 must be minus 1 and minus 1. So by solving our quadratic there, we end up with the highest common factor being t minus 1, minus 1. So we end up with t minus 1 squared, or t minus 1 is equal to 0. And therefore, we only end up with one value. T must be equal to 1 second. So in other words, this is our time of flight. So now I know that if I want to find the range, well, my range is when t is equal to 1 second, the time of flight. Now we saw already that s of x was equal to 9.8t, so therefore s of x is simply just 9.8 meters. So in other words, that's my range. So now we only have one more thing to do. If I go back to the original diagram, we now know the range. We know the height of the triangle is 4.9, so we just have to do Pythagoras to finish to find PQ. So I'll go on to the next page there. So I'm going to draw a nice little triangle there, showing us what we have. So we know this is P, this is Q. We have said that this is 4.9 meters. We've worked out the range to be 9.8 meters. And if I call this theta, it's not beta, because beta is, again, if you go back to the original diagram, the angle of projection alpha, I should say, sorry, is 45 degrees. That is not the angle here in this triangle. We don't know what the angle is. But if I call that angle at P there, theta, then 4.9 will be the opposite, 9.8 will be the adjacent, and PQ will be the hypotenuse. So therefore, from Pythagoras, we know that h squared is equal to O squared plus A squared. And therefore, PQ squared must be equal to 4.9 squared plus 9.8 squared. And if I get the square root of both sides, then that gives me the square root of 4.9 squared plus 9.8 squared. And therefore, PQ is equal to 10.96 meters. And again, we weren't asked to do it in terms of surd form or decimal form. So let's have a look at our mark breakdown. So this was a 20 mark question, so a nice little question to get you started in the projectiles that year. And the first 5 marks was for getting your SY equal to 4.9 meters. The second set of 5 marks was going for getting the time of flight. The next one was for getting the range equal to 9.8 meters. And the last set of 5 marks was for working out PQ. And you could have also had that in surd form, which was 4.9 root 5.